All right. So we talked about the chemical symbol. That's what those big letters are, like right underneath the atomic number. And the very last number, because you do have another number in each box of the periodic table, is what is called the atomic mass. And you see that labeled in your picture. It says that the atomic mass is 55.847, I think? 847? I can't read it, it's very blurry. But anyways, the atomic mass is simply an average mass. Keep in mind that elements can have isotopes. All an isotope is an element that has a different number of neutrons compared to other atoms of that element. So if it's got a different number of neutrons, we have to keep in mind how we figure the mass of an atom. The mass of an atom is basically just the mass of its nucleus. So if you're changing the number of neutrons in the nucleus, you're changing the mass of that particular atom. So the atomic mass that's written in a periodic table is always going to be an average because isotopes, there are isotopes of the different elements. So that's why you see things that say point blah, 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 blah. It's because it's an average. So let me get you the definition that you need to copy down. Awesome. Paper clips are awesome. So, average atomic mass. An average mass of all the isotopes of an element. The average mass of all the isotopes of an element. Don't forget, you've got the power of pause and rewind in case you missed that. Dun, dun. All right, so those are the 4 details that are involved in every single square of the periodic table. They have this information for every single square. Keep in mind each square represents a different element. So what we have now is we're going to go a little bit into how we organize this. Now in social studies, you guys are familiar with latitude and longitude, which help you pinpoint an exact location of something on a map or on a globe. What we have in the periodic table, you know, in case you can't remember what the atomic number for cadmium is, I can't imagine why that would happen, but an easy way to locate different elements on the periodic table is, it's kind of like latitude and longitude, only they're called groups and periods. So you have a little picture, or at least you should, somewhere on your notes that kind of shows you what a group and a period is. So I really invite you, please be looking at your notes so that you can see it. But a group is just basically a vertical column in the periodic table. And groups are pretty important. You'll see. Wait. You see how that one's kind of raised up? They're pointing out a given group. So a column, think of the columns like in a church or in wherever you see columns. But these columns are groups, and a group is really important because the elements of a particular group tend to have similar properties. So they tend to be reactive in the same way. Like for example in column number 18 or group 18, the properties of these guys are that they're not reactive at all. It's almost impossible to get them to combine with other elements because they react so little. 17, however, group 17, it's incredibly reactive, like some of the most reactive elements in the whole periodic table. But each kind of column or each group has its similar properties. So I'm going to define group for you guys, and I'm going to have you write that down, please, and thank you. Oh, my paper clips are failing me. Okay, so we have a group, which is a vertical column in the periodic table. Elements in the same group have similar properties. It's just kind of an extra piece of information there because it's helpful and useful. I want to help you. All right. Group, vertical column in the periodic table. Elements in the same group have similar properties. Press pause if you didn't see that. Okay. All right. So the last thing that we have, if we talk about latitude and longitude, so far we're able to recognize things with, I guess it would be longitude columns. Now what we have is the latitude period. Period is the word that we use for the horizontal rows, and all that it is simply a horizontal row. There's not too much to it. They don't tend to have similar reactive properties across a period. It's just, hey, we're all in the same row. Awesome. So, period is a horizontal row in the periodic table. Very exciting. Okay, horizontal row in the periodic table. Don't forget to press pause. So you want to make sure that you save this. This is all that we're really going to talk about for our notes today. It's just giving you a brief bearing of how the periodic table works. So make sure you save this or put it someplace safe in your binder, and then move on to the next item on Weebly. Bye.